Welcome to Emilac Online tutorial. Before us is this topic, the concept of limit. Actually, we'll be looking at what limit is all about and what it means when it comes to mathematics, calculus, and in algebra. And we'll also be looking at how to solve problems involving limits. All right. Now, first of all, let me write this. Okay. Now, this is just a general symbol that depicts what limit is about. Now, in a general sense, we can interpret this as the limit of the function of x as x approaches a equals a. Alright? Now, why I choose to differentiate these two values is the value of this a is not the same as the capital A. Alright? Okay. But they are both also variables. Alright. Now, if we are able to understand the interpretation of this, now what then is a limit? Now, limit in actual sense is defined as a value that a function approaches the output for the given input values. Now, what does this mean? Is now when we talk about the definition of limit, now I said is the value that a function approaches, okay, and the result of that output is based on the input, okay. Now, which means that the limit of this function here as x approaches a gives you this capital A. Okay. Now, and take note that when it comes to limit, as this x approaches a particular value, so is this function also approaching a particular value. Now, let us consider this, that f of x now equals x raised to the power of 2 minus 1, then all over x minus 1. Okay. Now, looking at this function here now, if we plug in 1, now it implies that wherever we see x, we plug in 1, right? So it lies here that 1 raised to the power of 2 minus 1, now into 1 minus 1, okay? Now, and this will definitely give us 1 raised to the power of 2 will give us 1 minus 1 all over 1 minus 1. And you know, this will end up giving us 0 over 0, which is, let me see, it is meaningless or undefined, right? Now, at this point now, this function is just meaningless. Why? Because we now have an exact value when inputted into the function, now gives us an undefined solution, right? Now here it is at this point that limit comes to play. Now let us now say, for instance, now that f of x 1.1, right? Now when we plug in 1.1 raised to the power of 2 minus 1, then all over 1.1 minus 1, right? Now, if we solve this, now we will have the answer to be 2.1. Now, if we also tend to probably this 1 here now moving closer to 1, right? Let us say this is 1.01. Okay, let me say as x equals, now f of x also will now be 2.01. Okay, Now, if x also is 1.001, f of x also will be 2.002. Same thing if x equals 1.0001. Now f of x now will be 2.0001. Now if you look at this progression, you will see that x in this case, now you can see from here, let's see from here that x equals to 1.1, then our f of x here is 2.1. Now you can see that when x equals 1.1, f of x is 1.2. I mean 2.1 rather. Now you can see that an introduction of x moving closer to 1 now gives the function of x moving closer to 2. You can see that you have 1.1, it gives you 2.1. Now x here is 1.01, which means it's moving closer to 1. And in this case, 2.01 for the function of x, which is moving closer to 2. Now in this case again, 1.001, you can see it's actually still moving closer to 1. No, the more it progresses, it moves closer to 1. And in this case now, the function of x now is also moving closer to 2. And if we tend to have 1.00000000, now the f of x will also give us 1, 2, 3, 4, 5, 6, 7, 8. It will give us 2.1, 2, 3, 4, 5, 6, 7, 8. You can see as x approaches 1, f of x approaches 2. Okay, right. Now this is just the concept of limit. And take note that in general, when we are dealing with algebraic functions like this, and when a function approaches a limit value, now to find its value, we first reduce the function. We first reduce the function. Now in this case now, let us reduce this function. Now you know, according to the algebraic difference of two square, now which will give us a plus b, a minus b. Now if we look at this, it's same thing as saying x square minus 1 square, right? Because 1 raised to the power of 2 is 1. Then over x minus 1. Then here you have x plus 1. According to this rule, x minus 1 over x minus 1. Okay? Now in this, arriving at this point now, you can see we have a factor that is similar to the numerator and the denominator. We can now eliminate. We can see that we've now simplified this expression or this function to the lowest. Now at this point, we can now introduce our limit as x approaches 1. In this case, now you now plug in this value of 1. You have 1 plus 1 equals what? 2, which corresponds to this. You can see x. So as x is approaching 1, f of x is approaching 2. Okay, and take note that after inputting your value of limit into a particular function, and if it gives you 0 over 0 or infinity over infinity, it implies that you've not reduced the function to the lowest term. Okay, and it's very, very important when dealing with limit, you have to reduce the function to its lowest term before inputting the value of x, and that will also help. Okay, now this is just the basic of the concept of limit, and I hope you get to understand the logic or the principle behind limit. Now take note, it's very important when you have a function, reduce it first to the lowest term before you plug in the value of the limit, or the value, or the value of x. Okay, and when you tend to have in plug in the value and you have 0 over 0 or infinity over infinity, it implies you've not reduced the function enough. Okay, all right. After this video, I'll be solving some problems that relate to limits. Okay, and it is actually both internal and external exam based, be it WAEC, be it NECO, be it JAMB, and be it international exams. Okay, and I hope you enjoy this class. If you love what I've just done, kindly subscribe to my YouTube page, my Facebook channel, and ensure you share it with others. Thank you, and God bless you.